right. Well, hello, wonderful students. This is going to be the teacher graded assignment help video and the play pause it video. Why not use both? Okay, so if you're watching this on YouTube or the YouTube link, great. You can use this to help you complete the Unit 3 teacher graded assignment. All right, so Unit 3, we have the quizzes, we have the quiz help videos, we have the textbook, and then I also uploaded the class recording that we went over some of the unit test questions. If you want to or need to, go ahead and check those out. 309 graded assignment, or the part 2 of the unit test, that's what we call teacher graded assignments. If you're just joining us, that's what we need to do. That's what this is for. I love teacher graded assignments, and you guys are welcome to solve these any way that works best, which includes pencil and paper. Okay? You're welcome to use pencil and paper, take a picture, and upload it. That's always a valid strategy. I'm going to go ahead and download the Word document because I have the draw function. Last time we went over different ways to complete the assignment without the draw function because not all of you have the draw function. So like I said, whatever creative way that you figure out how to complete these is perfect. But don't just give up. Do look for ways to solve them or complete them, like this play pause it. If you're watching this as a help video, if you're watching this as the play pause it, or you're watching it as a help video, you're like, I can't draw on this. I don't know what to do. Great. Pause this, go back to our class, and find the play pause it option, which will be directly under the original link. And we'll look at where it's going to be. It's not there yet because I have to make the video first and, like a time travel, like a time loop. It's impossible unless I do video editing, which I hate. So we're not going to do any video editing. So you're just going to have to figure out where it's at for the play pause it Unit 3 option for teacher graded assignments. So we've been talking about function models, right? And that's a big idea of math. We model the world around us. You'll hear mathematicians say, well, math is the language that we use to talk about the universe. It's true, but you don't need to use math to talk about the universe that you see and the things you notice and the patterns you observe. You can just talk about them however you see them. Then if you take more interest, then pursue some of the technical language or technical skills that you would need. Everybody does that depending on their career or their passions or their hobbies. There's a lot of gamer lingo for individual to unique to games. Like not just, I play video games. That doesn't mean anything. What game do you play, right? That's what's meaningful. The table shows values of a function f of x. What is the average rate of change f of x over the interval from x equals 5 to x equals 9? Show your work. Okay, if you don't remember how to find the average rate of change of a function, then look it up, either in your book or the internet. Search average rate of change of a function. It will pop up this formula. You can hear the quail. There are algebra quail. They are agreeing and they're telling you, good job, keep going, don't give up. I speak quail. All right, I think there's a doves. They're not even quail, but I like quail better. All right, that's it. That's the formula. It's the average rate of change. What is this thing? Well, this is just a fancy way of this old school thing, y sub 2. Maybe you remember this, maybe you don't. Y sub 1, just a y value, over x sub 2, over x sub 1. And that, friends, is just a fancy way, and this is another fancy way. This is the delta, the Greek symbol delta. Change in the y values, change in the x values, an even fancier way of just saying our old-fashioned friend, rise over run. Rise over run. It is the slope between those 2 points. Now, x equals 5 and x equals 9 are our x values from the point x equals 5, comma. We'll figure out the y value in a second. And x equals 9, comma. We'll figure out the y values in a second. That's it. That's what the average rate of change, that's how we find it within functions between 2 points. We'll get more fancy when we get into calculus, because calculus has a lot to do with rate of change. And why that's important to us, well, again, functions are used to model real life systems or stuff that's happening. all kinds of stuff. So we're going to leave it there for now. All right, back up to here. We have our x values. Those are just directly given to us. Now we need to figure out our f of x values, the output values, the y values. Well, we can do that in our table. They tell us in a table. So let's go find 5. Okay, here's x equals, there's 5. There's -2. Okay, so that's our y value. That's our f of x value. This is our f of 5 value. Okay, now we need to go to 9. So find x equals 9, 9. This is our f of 9 value, our output, our y value, that's 14. You don't have to show all of this if you're doing this on your paper. I'm just really trying to lay it out for you guys so you start to get the connections on how to read a table of values in function notation and how to put it into the formula, okay? That's exactly what this means. F of b minus a, well, this is going to be our a because it's the lower value. This is going to be our b. So now we just substitute in everything that we've already found. So I need to scroll down a little bit. Let's go back. Okay, let me zoom in a little bit. Scroll down a little bit. And we'll switch to green because I think it's larger. So f of b is going to be our f of 9. So we're going to have f of 9. I'm going to write the whole thing out. F of 9 minus f of 5, because that's our a, our initial x value. F of, we plug it in. 9 is b, 5 is a. Sweet, we're almost done. 9 minus 5 is 4. F of 9 is 14. F of 5 is -2. I have to put that parenthesis because we're subtracting. And now you have a double negative. Negative and a negative is a positive. So this would become +2. So you get 16 over 4. And then finally, switching back to purple, 16, because this becomes negative and negative, becomes a positive. This is what I do. It's now plus. 14 plus 2 is 16 over 4. 16 over 4 is just 4. Okay, so the average rate of change for this function for question 1 is just 4. From the interval x equals 5 to x equals 9. What does that mean? Well, in order to get from x equals 5 to x equals 9, we're going to go up 4 over 1, up 4 over 1. And if you plot that pattern, you'll see we will eventually arrive at 9 and 14. Does that make sense? If we increase by 4 every time, we'll eventually get to 14. I don't know. Don't worry about that. The rate of change is saying it's 4. For every time we move over 1, we go up 4. That's how it's changing. The average rate of change, the slope, the change in y with the change in x, rise over run between those 2 points. This doesn't have to be a line. It could be a parabola. It could be an exponential equation, a logarithmic equation, a logistic growth equation, and we're trying to find the slope between 2 points. It does not have to be a line. Okay. Question 2, we need to find a combination of a function, and this is just notation. Truly, this is literally just understanding function notation. So let's talk about it. Let's change it though. I like orange. Let's make it a tiny bit thicker. Perfect. We have our f of x is defined by this, 4 times x squared plus 6x. This is f of x. This is just its name. This is g of x, 2x squared plus 13x plus 15. That is g of x. This is just the name. Over here, when we put this symbol, f over g of x, so f divided by g of x, that is just a combined function, and all it means is we take f of x and we divide it by g of x. That's it. Okay, so let's go to dark blue. Why not? So let's do that. So here's f of x, 4x squared plus 6x. All of that is being divided by g of x, which is 2x squared plus 13x plus 15. Cool. At this point, we're going to want to divide. We're going to want to simplify and see what we can do with this. You're welcome to go use Symbolab or PhotoMath. Write out the steps, though. Write out the steps. That's how you will start to learn if you don't already kind of know what to do. What we're going to do now, and you're welcome to follow along as well, we're going to factor. That's the strategy here, you guys. You want to factor the numerator, factor the denominator, and then you can try to simplify. We have a warning. We have a domain restriction, which doesn't tell you here, and you should mention it. You should mention it because it's a good thing to mention. It's an important thing to mention. We have this entire function, g of x. Remember, g of x cannot equal 0. So you're going to need to find values of x that make it equal to 0. So we'll find that in a second. Let's factor. Factoring the top, the numerator, I'm looking for numbers they have in common or variables they have in common. 4 and 6 are my numbers. Do they have any factors or numbers that multiply together to equal them that are common? Well, think about it. 4 can be written as 2 times 2. 6 can be written as 2 times 3. Aha! They both share a 2. So I can pull out a 2 and I can pull out a 2. X squared and 6x. Okay, they both have an x. Clearly we see that. Hopefully we see that. If not, that's okay. So this 2x is what I'm factoring out. I'm pulling it out. So over here with the 6x, if I pull out a 2 or divide out a 2 and divide out an x, well, the x will go away and 6 divided by 2 will be 3. So we write plus 3. For x squared, there's 2 x's, x squared, so we're definitely going to leave an x there. But when we have that 4, taking out a 2 or dividing out a 2, we'd be left with a 2. You can check it really quick. 2 times 2 is 4. X times x is x squared. 4x squared, check. 2 times 3 is 6 times x is 6x. Perfect, we're good. So now this is a math test. It's written by somebody to assess some knowledge. Odds are this is going to factor. So this is a pro tip. The odds are, it may or may not be true, this will factor into 2x plus 3. This will factor into 2x plus 3. So the hard part is going to be trying to figure out what is the other factor. We don't know. We know it's going to be something x plus something. We don't know, but that's most likely what's going to happen so that we can simplify it. We need to go figure it out though. All right, 2x squared plus 13x plus 15. This is a quadratic expression that we would like to factor. It doesn't have a leading coefficient of 1, so to figure out what it's going to factor to, we have a special steps that we go through. We're going to multiply the 2 and the 15 to figure out what to split or change this 13x into. Ooh, I think it's 3 and 10. I bet it's 3 and 10. Okay, watch. 2 times 15 equals 30. Psh, can't write 30. We split that into its factors. It's 5 and 6, 2 and 15, 1 and 30, 3 and 10, right? You can list them all out, but we're looking for something that's going to add to 13. So that's why I like 10 and 3. That's what popped in my head. 10 plus 3 is 13. That's great. And 10 times 3 is 30. Now, we're not here. We don't get to jump directly to the nice factoring, but we have to instead split this up, factoring by grouping. If you have another way or another strategy that you like, you are allowed to factor by grouping any way you like. I'm actually going to do 10x over here, and then I'm going to do plus 3x over here. That's how I split up 13x. 10x plus 3x is 13x, and then plus 15. Right? The 2x squared and the plus 15 stays the same. The only thing we're changing is that 13x. The way we decided how to change it was this strategy of multiplying the leading coefficient by the constant, figuring out factors, and then which ones split nicely to equal the middle term, the linear term. Grouping, 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 right? We're going to group it. Cool, so now I'm going to factor out a common term from here. It's going to be 2x. Ha 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 ha! We found it. It's going to be 2x right here. That's my suspect already. Look, this has an x. This is an x. That's a 2. 10 is even. All even things are divisible by 2. Let's keep going. This one will now become, this is not division. This is just underlining. Not division, just underlining. So this 2x will become 2x. We'll pull it out. Boop, boop. We're left with just an x. Over here, we're left with 5. Because 2x times 5 gets me back to 10x. Or 10x divided by 2x, I'm left with 5. Think about it, okay? It's an important process of factoring by grouping. 3x plus 15, there's no x over there, so we just look at the numbers. Is 3, 3's prime, so is 3 and 15? It is! Let's pull out that 3. So this 3x, we took out the 3, we're left with just x. If we take out a 3 of 15 or divide out a 3 of 15, 5. Another strategy is this hint. Hint, hint, we want those to be exactly the same because now we have figured out what goes over here. What goes over here is just a 1 and a 5. We figured it out. Like, where did that come from? A 1 and a 5. X plus 5 is the other factor. Okay, so right here, this is what's happening. We're going to factor out that entire x plus 5. So I'll write that up here. X plus 5. Then we figure out what we write left. What's left, or write next, what's left is the 2x plus 3. Boom. Almost done. Okay. At this point, I would pause and think to myself, what values of x, pause solving moving forward, like you don't have to pause the video. X plus 5, 2x plus 3. I'm just going to look real quick right here before I simplify. Well, if x equals 5, negative 5, that whole thing will equal 0. So x can't equal negative 5 because the 0 property of multiplication, anything times 0 is 0. Over here, maybe you don't see it right away, but if x equals negative 3 halves, that whole thing will equal 0. Okay, I set 2x plus 3. I set it equal to 0. You bring the 3 over. It's minus 3. You divide both sides by 2. I can do it in my head. If you can't, write it out. Set it equal to 0 and solve for x. It's a good skill to practice, especially for the upcoming ACT. It's a 2-step. Setting this equal to 0 and solving is a 2-step problem. 3 if you count the setup. Look, they have common factors. Now, common factors are important when we're dividing polynomials. They must be multiplied. They cannot be factored out or canceled out, when it's the top and the bottom. When they're adding and subtracting, you can't divide them out. It must be multiplication. So you look for things that are being multiplied that are exactly the same on the top and the bottom. 2x plus 3 inside, yep, same as 2x plus 3 down there, boom. And we are done. 2x over x plus 5. That's it. We're done. We wrote our domain restrictions. Thank you for that. That's it. Okay. Last but not least, do you see what I see? Now, Mrs. Reynolds would probably prefer to use a graph because it's quick. We can type it in. We can see where they are the same, but that's not what they're asking of you. They're asking you to use a table of values. So that's what we're going to do. We're going to go up here. We're going to hit return because I don't want to be up there. We're going to hit insert, table, 1, 2, 3. Why 3 columns? Well, x, f of x, g of x. I don't know how many. Let's just do 5. Control bold, x. I did control B, f parenthesis x. Oh, it doesn't need to be capitals, sorry. Control bold, G parenthesis X. Oh, it auto-capitalized itself. No, thank you, computer, thinking you know better than me. See? Is AI such a good thing, guys? It just made more work for me because it thought it knew better than I did. Okay, anyway. All right, so now let's see when they're equivalent to each other. That's a line. And that's a parabola. How do you feel about like 0? Should we do -1? Just in case. 0, 1, 2? I don't know. When you make a table of values, this is how you start. So it's up to you. If you want to do something different, you can. So we just pick some numbers, making a table of values. I like to use easy ones. -1, 0, 1, and 2 are relatively easy. Then you're going to substitute them into f of x and g of x. I'm actually just going to type it out for you. So in this case, you would have -1. Here, wait, let me use the correct thing. Let's go home. Insert, equation. Here we go. We're going to type the equation, all right? So we would have -1 squared minus 6 times -1 plus 8. That's going to be equal. -1 squared is 1. -6 plus -6 times -1 is +6 plus 8. So that's going to be 15. I'm just formatting. Sorry, you guys can. So we have more space. I'm trying just to grab just the bar. That should be fine. Okay, so then I'm going to do the same thing for g of x. We're just going to do -1 minus 2. That's just equal to -3. Okay, they're not equal. Let's go to 0. This one's pretty easy because like you'll have 0 squared is 0 minus 6 times 0, which is 0, plus 8. That just equals 0. So that just equals 8. Okay, let's see this one, 8. 1 minus 2, 0, no, that's just -2, right? Because if we plug in 0 right here, we're just left with -2. Okay, 1, let's plug in 1. Okay, 1 squared is 1 plus or minus 6 times 1, well, that's just -6 plus 8. That is equal to 1 plus 6. 1 minus 6 is -5. -5 plus 8 is 3. And you can use a calculator. Over here, we have 1 minus 2. And that is equal to -1. Okay. Well, we're getting closer. We know we're going to go, see how it's going, -3, -2, -1. We're getting closer to where they're equal. I really don't like this. I really want to go graph it. Because the condition is table of values. Let's just keep going. All right, I'm just complaining. I'm not going to use the function. Just 2 to the 2 minus 6 times 2 plus 8 is equal to 4 minus 12 plus 8 is equal to 0. Oh, 2 minus 2 is equal to 0. Hey! So we found at least one solution. Do you see that? If we plug in 2, they both equal 0. That is what we want. That's pretty cool. So it's not only is that a y-intercept, an x-intercept, it's also where they equal each other. So here's the problem though. That's a parabola and that's a line. So using a table of values, we have no way of knowing if that's the only solution, like because it could be just one solution, or if it's there's another solution. Because remember, with a line and a parabola, here I'll draw it. We have 3 options when we have a parabola. Let's just do a standard parabola, right? Because that's what this is. And a line, we could intersect twice. we could just barely touch right there just once, or we could miss altogether. Right? How mean would that be if this was a table of values that there was no solution? That means we would just keep trying number after no solution. SOLUTION. No solution. Solution. That would be horrible because you would just do a table of values over and over and over and over and over again, and you would never have one that works. That's why I like graphical or algebraic. So now I'm going to solve it algebraically and not graphically, even though I wanted to solve it graphically. But here, if you wanted to go graph this on Desmos, you could go see if it intersects once, twice. Well, we know it intersects at least once because we found one. Haha. You could be done if you want to, but you're watching this video, so no. Haha. Here we go. We have, I'll solve it up here. No, I won't. X squared, I need to zoom out a little bit so I can write it. Okay, we have f of x squared minus 6x plus 8. Find when it equals g of x. So guess what? Just write that equal to x minus 2. To algebraically solve, we want to set one side equal to 0. So hopefully you're okay with this. I'm going to subtract x and I'm going to add 2. I'm going to do it right at the same time. Why not? Doesn't matter. Negative 2 plus 2 is 0. X minus x is 0. That whole thing equals 0. Now I'm going to go line it up with things that are the same. So plus 2, I'm going to add 2 here. Minus x, I'm going to do minus x here. So 8 plus 2 is 10. Negative 6x minus x, so that should be minus 7x plus 10, and then x squared. Well, if this is factorable, we already know a factor, and it's this one right here. We found one with our table of values. If you remember back in unit or first semester, that's cool. That means one of the factors, this is x minus 2 is a factor because by plugging in x equal to, you get y equal to 0 or the output's 0. That's a factor. Okay, anyway, so we know one of those. So now we're just going to factor this quadratic expression. Since I already know this one, it makes it so much easier to try to figure out the second part. And then we'll have our second solution if there's a second solution. There is. Okay, so x squared minus 7x plus 10. If we take out this first x, and we're going to reverse FOIL, how do I get back to x squared? Just x squared, so just an x. Cool. Well, now we need this last term to be plus 10, positive 10, and I have to multiply the last terms, FOIL, F, first, outer, inner, last, by each other. So negative 2 times what equals positive 10? All right, negative 5, because negative 5 times negative 2 equals positive 10. So now we can check. We'd have negative 2x minus 5x. Do those combine to make negative 7x? Hopefully they do. They do. All right, beautiful. So now we know we found one solution. There's definitely two solutions. The graph will look like that. We will have one solution at 2, 0, and we'll have another solution at 5. I don't know what it would be. 5 would be 5, 3. There we go. Those would be the solutions. The points of solution, the points of intersection. That's what I'm writing over here. All right, so then in order to complete this next one, if you wanted to do this algebraically, you could just add 5. And when we add 5, we can say that, okay, it's going to be 3. Over here, we'll prove that it's 3. 5 squared is 25. Minus 6 times 5, which is minus 30, plus 8. 25 minus 30 is equal to negative 5, plus 8 is equal to positive 3. Boom. We proved it. They're both solutions. And this one is right here. I just did 5 minus 2. And that's equal to 3. this is the Unit 3 TGA. We talked about a lot of skills. Thank you for watching, and I hope that this helped you with trying to complete it by yourself or just in the play pause it. Answer those questions. Remember, get 100%. You should have unlimited tries, so don't accept anything less than 100%. When it's like a game, you can just go back and respawn, try again. Okay? All right, good job, you guys.